Welcome, 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 welcome. Okay, what are we doing? We are talking about the abacus. We love to talk about the abacus. I'm almost done. I'm actually quite excited. So then we're going to be starting to look at the abacus. What are we doing? We are going to be counting on the abacus. So here is my abacus. This is a counting tool. This counting tool helps me count. And it also does adding, subtraction, multiplication, and division. But wait, there's more. Okay, the first thing we're going to do is we're going to count. 1, 2, 3, 4. All the lower beads has the value of 1. Anytime they're touching this horizontal bar, hello, Alejandro. So here, because this is my horizontal bar, these beads are being counted. Because these beads are being counted, this is 4. We know this is 4. 1, 2, 3, 4. But wait. Where's 5? 5 is right here. 5 is always going to be the top bead. The top bead, which means anything above this horizontal bar. So when we're looking at it and it's facing towards me, this is the top bar. This is the top bead. These are the bottom beads. Over here are the bottom beads. Because these are the bottom beads, these all have a value of 1. This always has a value of 5. So all of these is 5. So wait, let's just keep going because I already know what they mean. Okay, fine. So we have 5 and then 6. And I like to talk to myself. But please, let me know if you have any questions. Because if not, I'm just going to continue rambling. Let me know if you have any questions. So we have 6. 6, 7. How do I know? 5, 6, 7. 5 plus 2 is 7. And then if I do that, 5 plus 3 is 8. So when we look at it, we see that this is 8. And then this is 9. How do I know? Anytime these beads are touching the horizontal bar, these are being counted. They're being tracked like the government is bugging us, like the government is tracking us. So the horizontal bar is kind of like the government, like it's trying to track us. Anyways, so this horizontal bar tracks these beads. This is 9. How do I know? 5, 6, 7, 8, 9. That was a really conspiracy theory right there, but that's not what I'm trying to do. What I'm trying to do is I'm trying to read the abacus, because we need to read the abacus. When we understand how to read the abacus, we will then be able to learn how to add, subtract, multiply, and divide. However, the first thing we need to do is understand how to read the abacus. So then you're like asking, hey, wait, what about 10? Well, 10, just as we write 1 and a 0, right? 1, 1, and 0. Tens and ones, just like our place values, we have our ones and our tens. Does that make sense? Anybody have any questions? Oh, maybe I should bring that down. Anybody have any questions? So if you look, that's not right. If you look, thank you for the likes. If you look, we have our 1 and 0. How do I know? Because none of these beads are touching the horizontal bar, so these are all zeros. However, now we got to start looking at our place value. As we look at our place value, we have our tens, our ones, our thousands, and our 10,000. What does that mean? Well, on the abacus, we talk about place values because we have our ones, our tens, our hundreds, and our thousands. So as we're looking all of this, it's interesting to see that the abacus helps children or people, young people, old people, person, to be able to keep their place values. So that's the thing about the abacus, is that the abacus helps keep our place values. That means this is our ones, our tens, our hundreds, our thousands, and our 10,000. Just as we have our place value here. This is 10. So if I continue to count, this is 11, 12, 13, 14. After 14 is 15. 15 again is going to be the top bead. Because this is the top bead, this is 15. 1 and a 5. So then if I did this, this would be 65. Why? Because it's 5 and then 6. 5 plus 1 is 6. Notice that? Do we see that? Are we all right? Are we tracking? Are we being a horizontal bar? Let me know if you have any questions, but we're going to continue to count on the abacus. We're going to learn to read the abacus. Let me know if anybody has any questions. People come in and go, and I don't know where we are. Okay. I'm going to continue to count because the idea is to understand how to read the abacus. Once we learn how to read the abacus, we will then be able to do arithmetic. But the first thing we need to do is understand that this is going to be 3. Because this is 3, 1, 2, 3, we know that this is 6. This has a value of 5. This is a value of 1. Together, they make 6. How do I know? 5, 6. And then if I did 7, That would be 7. Now, what about all these other beads? Well, these columns are our place values. So we have our ones, our tens, our hundreds, our thousands, and our 10,000. And then there's the decimals. So if you notice, the decimal actually sits between the ones and the tens. So when we're writing this, what number is this? What, if anybody can, oh, hey, JP, let me know in the chat what number this is. Let me know in the chat, what number do you think this is? And I will write it. I'll write it. So that the number is 3, 6. Hey, Earl, yes. 6, 5.7. Exactly. Yes. Yes, JP. JP, we have to have the decimal. That's where the tens place, because remember, this is my indicator. So I have this indicator that tells me this is the ones place. Because this is the ones place, this is where I have my home. This is where I choose my home. So when we talk about it, we want to make sure we remember that this is the ones, and then this is the tenths, and this is the hundredths. So when we look at it, we have hundreds, tens, ones, and then this is the thousands. So if I did this, this would be 9,000, 9,365.7. So that's what this would be. This would be 9,365. This is really horrible handwriting, but it is what it is. Anybody have any questions? Anybody have any questions? If we're not, we're going to continue on learning how to add. Okay. Okay, it seems like everybody's okay. Oh, you know what? Here, you know what? Before I go, let me ask you what number you think this is. How about them apples? Okay, so if I did this, this, yeah. All right. So what number do you think that is? Okay, what number is that? Put it in the chat what number you think it is. It's Alex! Hi, Alex. Hey, JP. Okay. Let me know what you think this number is. Now, don't forget, this is our ones. So if this is our ones, this is our tens, our hundreds, our thousands, and our 10,000. So just as we write it, what number would this be? Let me know if anybody has any questions. There's not a lot of people talking. This is a conversation. I want to have a conversation about abacus. Anyways, I'm sorry. Yes, Earl. Let's see. 20,000. Thank you, Nash. Thank you, Earl. 678. Yes, exactly. JP, you still around? Are we all right? Does that make sense? Hey, Ray. Okay, what are we doing? We're gonna continue on. That makes sense? It's okay? All right. Yes. I'm sorry. So we had 20,000, 20,000, so 2, 0, and then we had 678. So we had 678. And you're right, the comma would be nice to have there. What's the dot on the left for the... oh, I'm sorry. I'm sorry. What's the dot to the left beside the thousands for? This one right here is to show that it's the thousands, just like we have the comma. So when we're writing, it's just like we have the comma. And it's kind of cool because if we have more, it's easy to see. So that means if I have this one, then this is the thousands, and then this one would be the millions. So it's easy to label, right? Just like our decimals. And a bunch of icons. I don't even know what you're... okay, kiss and dinosaur shark. Okay, how do you read it? We're going to read it. Thank you so much for asking. But I don't know how to say your name because you're a bunch of icons. Okay, this is how you read it. This is how you read it. 1, 2, 3, 4. Are we all right with that? Why? Because this is the horizontal bar. The horizontal bar is what tracks the beads. So what that means is this is considered 4. Why? Because now we are these beads are touching this horizontal bar. When any of the beads touch the horizontal bar, yeah, not a problem, Nash. Let me know if you have any questions. So let me scratch this out. Okay, we have 4. After 4, we have 5. That's not 5. This is 5. This is 5. How do I know? Because this is 1. All the top bead has a value of 5. So we have 5, 6, 7, 8, and 9. As we look, this is 9. So each column, each digit has a value of, has 9 beads, quote unquote, 9 beads. Why? Because 5 is not really 5 beads. It's just the value of 5. So this would be 9. This is 9. This is 9, this is 9. And if you can, make sure that all the beads are touching. Why? Because then we talk about attention to detail. Attention to detail. So when I clear it, this is 0. So we would do 1, 2, 3, 4. But this is also 4. However, this is 40. This is 40. Why? Because it's a 4 and a 0. We, just like how we have place values, can you show some arithmetic once you're done counting? Yes! I would love to. That would be fantastic. Thank you so much for asking, Nash. All right. So we have our 1s, our 10s, our hundreds, our thousands, and our 10,000. As we go, we have 40, 4, 0, and then we have 50. So the dinosaur icon with the lips and the shark, are we okay? Does that make sense? If not, I'm going to continue on and we're going to start adding and subtracting. But I don't even know how to say. I can't remember the last time I've been so excited. Whoa! Hey, Matt, what's it going? Right? Ah, okay, good. You're still here. So does that all make sense? We're talking about me too. You guys are so funny. So it could just be that this is a little secret and we're talking about secret stuff. So anyways, we're doing 9. No, this is not 9. This is not 9. Why? 5, 6, 7, 8, 9. This is 875. So when we look at it, we just need to know the numbers from 0 to 9. But then all we got to do is understand our place values. Does that make sense? Kowalski. Yes! Right? He had an abacus in his stomach and then he just threw it up. I don't eat abacus, but his abacus was a Chinese abacus. This is a Japanese abacus, which is a little different. It's a little different. So the top bead, so top is 5 when it's down, correct. And 1 below is touching up. It goes up. So when we talk about it, this is 1. When you look at it, that's 1, and then this is 2, and then this is 3. Because it's touching the horizontal bar, we want to make sure that the beads are touching the horizontal bar. If it's like this, then it's not anything. It's 0. Why? Because it's not touching the horizontal bar, and we need to kind of pay attention to detail. I like that word. Pay attention to detail. Why? Because when we look at it, sometimes the kids or people, just people in general, forget that there's this 5. Oh, I think I got it. Oh, fantastic. Right? Okay, good. Because we got it and we're okay, I'm going to continue on. If we want to, I'm going to start doing some adding and subtracting. Are we ready? Are we ready? Okay. I really like the abacus. I think it's the greatest thing next to sliced bread, and I think it's the greatest thing next to Betty White. God rest her soul. Bless her heart. Okay. Again, we have our ones, hundreds, tens, and ones. So we have to make sure we remember our place value. But the first thing we're going to do is we're going to understand how can you explain 9, 7, okay. So 6, 7, 8, and then 9. When I look at it, I want to make sure that I have the value of 5 touching the top bead. Thank you, Blue Candy, for the question. So when we look at it, this is 9,876. So as we're looking at it, I love this. I wait for the sigh. Oh my gosh, you guys are funny. Why is the dot on the paper? That is a decimal, Albert. Just like we do decimals, right? And we do money. We do money. $7.25. That's what it is. That's why there's a dot on the paper. The dot is our decimal. So it mimics, Abacus mimics the way we write. So we have 7,000. Oh, that's not right. That's not right. $7.25. Just like that. All right. Okay, so we understand. Okay, so Blue understands we're okay with counting. Are we okay? Great. Sai, do you have any questions? Okay, Albert, did that make sense? Why there's a dot on the paper? This kid, 98. Oh my, I know how old you are. You know why? Because that's how long I've met my husband. I just learned how to use. Yes, Otter. Easy to use, simple to use, easy to understand. All it is just understanding how to read it. Once you know how to read it, then we can start doing adding, subtraction, multiplication, division. But it all depends on my. I start to go down. Oh hey, lips. How what? How? Help! Help! Okay, we're gonna count again. We're gonna count. So, AJ. We're gonna do AJ. AJ. Here we go. 1. Because how would you add? Oh, how would you add? So simple. I actually showed you a little bit about adding. If you notice, if I did a 5 plus 1 is 6. That's easy, right? All we're doing is we're moving the beads. So what we're doing is when we do this, right, that's adding 1. We're adding 1 bead. If we add 2 beads, right, this is easy. This is so easy. And it's simple to use. So it's 6 and then we add 2. So what is that? Okay, I'm going to move that. I got to move this. I got to do this. Okay, so here's my little book. My little book. I was trying to talk to like young kids and blah, 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 blah. Now, but we're going to talk to the big kids. The big kids want to know how to add. So the big kids are learning how to add. The first thing we understand is what we need to do is we need to recognize the add-ins. We're not in mainstream math, we focus on the result, but in Abacus, what we actually do is we focus on the add-in. That is a very key fundamental, that's the key difference between adding in mainstream math and adding in Abacus, just so you know. So what does that mean? The book is broken up to add-ins. I want to learn how to add 1 on the Abacus. So if I do 7, when I do 7, I want to add 1. So I'm going to add 1. The idea is to be able to see that I'm moving the 1 bead. This is very elementary. I understand. This is not to question your intelligence. We all see that it moves, right? We all know what's going on. Now, understand though, moving the beads, that's all we're trying to do. So when we add, we're moving to the horizontal bar. When we subtract, we move it away from the horizontal bar. So that means we have a little balance. It's not a 6-7. It's not a 6-7. It's understanding the balance. So when we add it, we know we have to move to the horizontal bar, just like here, right? We want to go to the horizontal bar. When we're subtracting, it's the same thing. We want to go away from the horizontal bar. So then the children and everybody else who looks at the abacus will understand that they're subtracting. Does that make sense? So if I have 3, I'm going to take away 2. All I got to do is, I don't even like math, but your energy is keeping me happy. Yes! I do like Abacus. I really do. And I've been doing this for a little bit now. Yes, right? Okay. But please know that when I'm talking, it's not because I'm talking down to you. Please understand that I'm really quite excited and understanding. Okay, good. Hell no. Oh, I don't know, Nick. If this is not for you, then that's fine. Because I'm not for everybody. I know this. Okay. So, again, we do +1. Okay, we know how to do +1. Let's do +4. Well, understand, +4 doesn't have a lot of numbers. +4, we have 5, so I'm going to add the 5. And then we add 4. Notice, do I have enough beads to add the 4? I'm going to add the 4. There we go. That's it. And so my answer is 9. That's all we need to know. Now, again, we need to understand how to read the abacus. Once you understand how to read the abacus, we will then be able to move the beads. Now, one of the questions was, well, what if there's not enough beads? That's when we start learning. Thank you, Ebony. Thank you so much for the rose. I don't know, Nick. Hell no, I don't know what that means. Hell no, we won't go. We won't go out of the live. Okay. Okay, so what I'm trying to do is I want to add 4. In mainstream math, we are taught to memorize our doubles. But if you notice, doubles only matters in addition. If you do doubles minus, what is that? That's just 0. That doesn't help. So notice it's only one way. Memorizing your doubles is only one way. Well, what about on the abacus? Well, on the abacus, we need to do, thank you so much for the tiny diny. What needs to happen is we need to start utilizing the beads that we have. I was like, what? I don't understand. Okay. Now, what's going to happen is I need to find some paper. Okay. I don't know if anybody remembers their algebra. Now we're going to start getting into abacus is the gateway to complex math. And so let's say we're done with this book, right? This is about simple adding and subtracting. We know how to move the beads. We're ready. We're all mad. No, I'm not mad. I'm mad about Abacus. I love Abacus. Okay. So the first thing we're going to do is we're going to understand how to add a 5. Why are we doing this? This is a fundamental concept. This is a fundamental concept, and this is going to lead into why we need to add the 4. Okay, so the question is 4 plus 4. That's what we're trying to do. What we're doing, is there a beginner kit? No, I'm sorry, Hannah. I haven't figured out how to make a beginner kit. I sell the Abacus on my website, and then I do sell the book. If you're looking for the book on Amazon, you can find it with my name. That's my name. How beginner, like, are you talking about like kindergarten, preschool beginner, or are you talking about like adult beginner? Because I'm still in the process of 7 beginner. I would probably start off with I'd probably start off, if you're okay with the theme, I would probably start off with the Christmas one. And what we do here is we do the same thing. We count from 0 to 20, but this time we actually do adding and subtracting like double digits. And that might be a better one if it's okay to do it themed. I haven't made a book that is not themed yet, just because I've been a little busy. I'm actually in the process of making more books. It's just one of those things that, it takes time to create these sort of workbooks, and I just kind of started. So, if that's okay, I have that. Okay. But yeah, you can find the Abacus. So if you're so for a 7-year-old, I would probably recommend the Rainbow Abacus because it's nice and colorful. If you have a Daiso around you, a Daiso, which would be DAISO, a Daiso. This is a 13-column abacus, and the reason why I do a 13-column abacus for the older, because the numbers get bigger. How do I get online training? Hey, Pap, if you want to DM me, we can talk about it. Yeah, let me know. If you're serious about it, we could talk about it. So let's have a conversation, because I like to have a conversation with my numbers, just like I have a conversation with people. All right. So we're back to here. But I do have pre-recorded if we're okay. I don't know. I need to know like your situation, Pap Solo. It could be for the kids or it could be you, but we could talk about it. So in school, we're teaching children how to do this. But now, okay, we're done with that. That's all they do in school. They just teach one way for school. This was this and that, right? That's it. Now, the question is, I'm ready. Just DM me, Pap. DM me, and then we'll talk about it. So notice, this is all they do. Now, what are we going to do? What we're going to do is we're going to supercharge this number sentence. We're going to supercharge this equation. We're going to understand, do you remember in algebra, we know how to isolate the variable? When we isolate the variable, what we need to do is we need to find the x. Thank you so much, Pap, for the join. Yes. Yeah, give me a DM and we'll talk about it. So here, what we need to do is we need to isolate the variable. To isolate the variable, just like in algebra, we need to move it over here. So we isolate the x. So it's 5 minus 1 is equal to x. So when we do that, if I replace the 4, notice that it makes sense. Now what I'm going to do is I'm going to substitute this equation into here. Does it seem a little bit long? Well, it's better to know this than it is to memorize our doubles. Why? Because doubles is very one-hit wonder-like. In the abacus world, because I know how to add the 4, this is a very crucial, thank you so much. This is a very crucial concept, just so you know. It seems like it's long. It seems like it's invested. But once you know the fundamental, you can move it anywhere you want. So here, if I have 4, I'm going to plus the 5, and I take away the 1. Do you see how there's a number pattern? There's a number pattern with that. So I want to plus the 5, take away the 1, and now my answer is 8. Okay, well, I don't know. That's too much to say. Okay, well, let's do another one. Let's do 2 plus 4. Well, what are you going to do? Are you going to learn your doubles and then minus 2? Well, if you're going to learn your doubles and minus 2, you might as well just, keep learning, memorizing more stuff. Or you can go back and understand this. If I want to add 2 and I notice I don't have enough beads to add 2, if I don't have enough beads to add 2, all I got to do is add the 5 and take away the 1. If you struggle with doubles, do you need to go back, is my opinion. Hey, nickname! Welcome back. If you struggle with doubles, you need to go back, is my opinion. You know, if doubles is doubles is really just memorization, right? At the basic level, maybe, but you can add and subtract this really fast. Yes, that's true, Earl. Because the thing is when the numbers get bigger, the concept is still the same. So even if we had like, I don't know, four, 24 plus 37, 43. The concept's still the same, but we don't do doubles, right? And so when we start looking at it, let's say 24. So if we do 24 plus 4, again, if I know how to plus the 4, I want to plus the 5, take away the 1. So I'm done with this. Now we're at 60. And then there we're here. Well, same thing with adding doubles. With the 3, is my is my is my add-in. The 3 I can focus on. We know what it is, don't we? We know how to plus the 5. So because I know how to plus the 5, I have 5 is equal to minus the 2. So when I want to add the 3, I just need to add the 5 and then take away the 2. So now my answer is 67. Does that make sense? So this is why we don't memorize doubles. What we memorize is the fundamental. Yeah, we memorize the fundamental formula. This is what you need to know. This is what, because understanding how to use the 5 is very critical, because it is part of the foundational piece. Does that make sense? Please. No, do that again. I see. So let's do 24, right? We know we want to add the 4. In Abacus, we talk about it as a whole like this. We don't do individual ones and then tens. What we do is we do the whole, and as we talk, it's 43, not 340. So when I want to add the 4, I don't need to know my doubles. What I need to know is my add-in. This add-in is adding only the 4. Because I know how to add the 4, all I have to do is plus the 5, take away the 1. Then here, if I want to add the 3, I know plus the 3 is plus the 5, take away the 2. So left to right, correct nickname. What we want to do is, it's just exactly how we talk, right? 43, not 340. And so in Abacus, it gets to be more. So in Abacus, we actually have more add-ins. So we're at, let's do 24, 43, and then we'll do, I don't know, 37. We'll do that. So in Abacus, we actually do more than just 2 add-ins. It seems elementary here, but the issue is understand the basics, understand how we get the fundamentals, and then it can scale no matter what. No matter what, it can scale. So now we're getting into bigger numbers, right? We're getting into more add-ins. Again, we do 24, and then I do 43 again, plus the 4 is plus the 5, take away the 1, and then plus the 3, plus the 5, take away the 2. Now I'm going to do some more, right? I'm going to do more. I want to add the 3. Okay, I added 3, not a problem. But now we get into an issue where we add the 7. When we add the 7 is a different thing. Why? Because I don't have any more beats to add the 7. This gets complicated quick. Why? Because now what we're going to do is there's a bunch of two-step equations. Two-step equations is very common in algebra. So Abacus actually introduces two-step equations very nicely. But the thing is you need to really be solid on adding the 5s and adding your 5s and adding your 10s. Does that, okay, so what does that mean? I have to figure out like how to, okay, this is going to get complicated really quick. Why? Because I want to add the 7. To add the 7, there's not enough beats. Notice there's not enough beats to add the 7. So what do? I need to plus the 7. I'm going to go slow. I need to go slow. So it's like counting up when you're giving change, sort of. Yes, exactly. It's like giving change. And that's exactly what it is. What we're doing is we're doing a lot of exchanging. It's just different because we also have place values. I know there's the blocks, and the blocks are also exchanging, right? So you have like little blocks. Like these blocks, it's exactly the same, but in Abacus we have place values. These ones don't offer place values, right? They just offer quantity. Whereas in Abacus we offer place values, right? We put it in place values. So, okay, let's take this slow. Let's see. I want to add the 7. I'm at the 7. I need to add the 7 to this number here. What am I going to do? Plus the 7 is equal to plus the 10 minus 3. This is how I am going to add a 7. Why is this a problem? Because if you notice, there's not enough beads to add the 1. Because there's not enough beads to add the 1, we have a 2-step, this is more than a 2-step equation. This is actually a lot of steps. This is a very this is a question that will this will push you to more advanced. Why? Because there's more to it. What we need to do is we need to analyze that we need to add the 10. To adding a 10 just means going to the next column over. That's all it is. I feel like the different way of thinking. Yes. Yes, Hannah. I like the different way of thinking. We're in a culture right now of hurrying to get the answer correct. Whereas in Abacus, we need to know the process. What do they say? It's like social media. Marry the process and divorce the results. Okay. Now, why are we doing this? Because we need to see that there's numbers and we can't add any more 1. Another way to add the 1 is not through the 5. Why? Because we're already using it. So this is a process of doing it. I always say that to the parents. They always like, why do so much? Yeah. And it's different because I know in new math there's a lot of pictures. There's a lot of pictures like, oh, this is, hundreds, and then these are the tens, and then these are the dots. And it's like, it's fine, but it doesn't talk about place values. It's good to see the quantity, just like these blocks. These blocks talk about quantity. But in the Abacus, we talk about place values. And now we start thinking about how to critically think about this. So this is why we have a conversation with our math. So my question is how do I add the 1? I already using the 5, so I can't do the 5, right? I can't add a 5. So the next number we need to do is we need to plus the 10. So what we're going to do, plussing the 10 only means to go to the next number. So we plus the 10 and we take away the 9. That's the formula for this one. So we're done with this. Does that make sense? The next thing we need to do is we need to add the 3. We need to take away the 3. Well, a problem is those are crutches at point. Yeah. And Abacus is not the end all. I'm not saying I'm not saying that this is like everything, because this is the gateway. This is a phase. So after the kids understand the quantity, then maybe transition them to Abacus. And then after Abacus, it goes into algebra. Because after we do multiplication, division on the Abacus, then they go into algebra and calculus and so forth. So Abacus helps, solidify foundational math. We're still here. This is a very long question because there's so many steps to it. And I apologize. So, just as I said before, we know how to add a 5. This is the same concept of taking away the 5. So when we take away the 5, we want to minus the 3. Can we take away the 5? Yes. All we have to do is take away the 5 and add the 2. Sorry. So my answer is 104. Sorry. Okay. Yeah. These are very helpful for quantity, but it doesn't help with place value. So there's a time and place for everything, and I agree with that. I agree that they're very helpful. Yes, I'm over. It is abacus time. I understood the adding, but my brain is not subtract. Oh, the only reason why we're doing this is because we're adding the 7. You still need to keep the you still need to keep this in your mind, because what we're still trying to do, the ultimate goal is to take away the 7. And if you look, and this is just the next step, right? If you look, I cannot take away the 3 because this is the question that we need to do. Does that make sense, nickname? So I'm still trying to take away the 3 here. And we're not, in this live, we're not strong in it because I don't talk about minus the 5 very often. So what we're going to do, just like we have 3 plus 2 is equal to 5, we need to understand minus 3 minus 2 equals to minus 5. This is still the variable and we need to move it over. So the formula is still minus the 5. It's just the operators are different. So I take away the 5 and I add the 2. Did that make sense? Yeah, okay. If that made sense, if that's okay. But yeah, I mean, what it is what it is to really understand how to take away the 5. If you know how to take away if you know how to add, all my questions are a lot of adding. I don't do a lot of subtraction, but we need to know this hand in hand. It's just like your left side and your right side. You have to be ambidextrous. That's what it is. So you have to know how to add and have to know how to subtract. So if you notice, if I want to add the 2, it's plus the 5. If I want to take away the 2, it's minus the 5. So they go hand in hand, and we build on this concept. We build on foundational information. Hey, Jesus. Does that make sense? Yeah. But, I mean, we just starting to learn it. The questions are usually adding. Excuse me. I'm so sorry. It's the allergies. There's a lot of wind coming up. Okay. So, thank you, Blue Candy. Thank you, Blue Candy, for the tiny. Thank you, Ebony, for the rose. So does that make sense? Okay, so what's next? We're still going to continue on. I'm sorry. So, here is a little bit. It's like walking with algebra equations. Exactly. Exactly, nickname. Exactly. Abacus is the gateway to complex math. And that was the thing. I was trying to look at... There's a lot of substitution that happened here. But the thing is you know how to do this, you will know how to do this. You just need to see what's there and what you have. And then the question is how do you do it? So if we looked at it, right, we had 90. Let's say we did 94. Let's do 94 plus 7. Right? When we do 94 plus 7, we have 94 plus the 7. When we add the 7, the equation to add the 7, because there's not enough beads. So what's another way to add the 7? Plus the 7 is plus the 10 minus the 3. But if you notice, there's no room to add the 1. There's no room to add the 10. God, that's horrible. So if there's not enough room to add the 10, how do we do it? How do we do it? We know we need to plus the 1 is equal to plus the 10 minus the 9. I know, I have water. It's just not helping. So we have the 10. 10 only means go to the next column over. We don't need to do plus 100, plus 300, plus 400. We don't need to do that. We just need to plus the 10. And it doesn't matter where you are on the columns. That's the thing. It doesn't matter where we are on the columns. It's always going to be the same. It just depends on the specific add-in that we're talking about. So right now, our add-in is plus the 1. We add one bead to the hundreds. And yes, exactly. So we add the one bead in the hundreds. And then we take away the 9. But see, I don't say it this way. I don't say 0 out the tens. What I would say is, I would repeat the equation. Plus the 10 minus the 3. The next one was plus the 1 is equal to plus the 10 minus the 9. So what it is plus the 1 is equal to plus the 10 minus the 9. So we plus the 10 minus the 9. I wouldn't say 0 it out. I would use what we have, right? So we build our vocabulary. We build the rhythm. So it's plus the 10 minus the 9 and then minus the 3. Do you see that? So we could say it different ways, but I think the other issue with math is that we have too many ways and it gets overwhelming. But if we bring it down to the basics, if we bring it down to what we're exactly trying to do, we're not zeroing it out. We are minusing the 9. So in our heads we can minus the 9, not zero it out. Oh, I see. Saying 0 would be confusing. Yes. And you know, the other thing is we're talking to children, right? We want to give them one framework. As we give them one framework, it's easy to get them to see the relationship. It's like get them to see, you know, how everything is. But that's why I try to be specific with my words. So when I want to plus the 10, I don't want to say plus the 100, because then it's really confusing. What I want to say is, so I have 94 again, right? I'm here. So my question is plus 7. I want to plus the 7. Notice my finger is pointing here. I want to plus the 7. I can't do it. I need to plus the 10 minus the 3. And I use my finger to help me know what I'm trying to do. I plus the 10 minus the 3. I cannot plus the 10. How can I plus the 10? Plus the 10 minus the 9 minus the 3. Do you see how I use all of the same elements, but I just move my finger. So it's plus the 10 minus the 9 minus the 3. So I plus the 10 minus the 9 minus the 3. See how there's a rhythm to it? So as you say it more often, you'll see that there's a rhythm. And as there's a rhythm, then you can just start moving everything around. So it would be the same thing with, like, say we had 40, let's say we had 49, and I want to add 5. It's the same thing. 49 plus 5, right? So would you do left to right if there's no more, I'm sorry. So would you do that going from left to right until there's no more rows? Yes. Till there's no more columns. Yes. And to get to the ultimate addition, right? The idea was to add the 7. So I know my last thing I need to do is either to minus the 3 or plus the 3. But ideally, if you can, let's go back to this, 94. Let's go back. So if let's say it's a really long question. Ideally, you would be versed enough to be able to say, okay, I want to take away the 3 first, and then I want to plus the 10. Can't do it. How do I do it? Plus the 10 is plus the 10 minus the 9. So I can plus the 10 minus the 9. I can minus the 9 now, and I just remember to plus the 10. So it doesn't matter the process, it doesn't matter what step you use. It just matters what the add-in you're using, if that makes sense. So if you want to keep track of it, you can do minus the 3 first and then plus the 10, and then minus the 9 first and then plus the 10. So it depends. It just doesn't matter. It just depends on what your flavor is. So we're back to this one. Let's say 49. So again, the question is adding 5. Well, what do? We don't have enough beats to add the 5. What do? Again, it's plus the 5 is equal to plus the 10 minus the 5. Well, we plus the 10, take away the 5. No, You're perfectly fine, nickname, because we need to understand. And if you don't ask me questions, then I won't know how to explain it. You know what I mean? Once you decipher what needs to be done, it doesn't matter what order you do it. Exactly, Barlos. Exactly. Don't be afraid with all the questions, nickname. I need those questions because I need to understand what you're talking about and where you're coming from. And to it's feedback, right? This is why we have TikTok. This is why we have conversations. Don't apologize for your questions. I love them. They're fantastic. They're great questions because if you don't ask it, nobody else will. And probably somebody has the same question as you did. There's a lot of people who will be like, "How come you're in the middle?" And I'm like, "Well, it's because of this indicator. This is my indicator. My indicator tells me it's the ones place." Okay? So, no, I will not accept your apology nickname. Do not be afraid to ask questions. You keep asking those questions. So here we're going to do 5. The question I have is, well, how do we want to add the 5? Add the 5 is plus the 10 minus the 4. So just as Barlow says, right? I want to plus the 10 minus the 5. I can take away the 5, right? I can take away the 5, not a problem. But the problem is here. I don't have enough beads to add 1. Remember how to add the 1? Can we utilize the 5? Yes. So how do you add 1? Adding the 1 is plus the 5, take away the 4. And my answer is 54. Does that make sense? So it's all about what is your add-in, and be very, I wouldn't say micromanage, right? But it's saying making sure you're taking one step at a time. The idea is to make sure you have one step at a time. Because if you do one step at a time, and then you got to keep track of those steps, right? So it's like, what? Hansel and Gretel going to go get their, going to the, what do you got? The witch's house, and they use breadcrumbs to keep where they're going. You have to keep the breadcrumbs in your head, just so you know where everything's going. Hey, Rain. So, does that make sense? Are we okay? Yeah? So we're going to count, because there's a couple of people that came in. What we're going to do is we're going to count 1, 2, 3, 4. Yes, so as far as the formula goes, it technically never goes above 10. That's correct. It never does go above 10. The two pillars is 5 and 10. The two pillars is 5 and 10. So really, if you really boil it down, any number, as big as the number gets, these are the four formulas you only need to know. The 4 formulas, the 4 pillars, the four things. Why? We want to be able to add and subtract 5. Here, add and subtract 5. And then add and subtract 10. That's all we need to know. And that's the crazy thing. When I started thinking about it, like more and more and more, and I'm like, we don't need to know so many, like, there's a lot of strategies to add, which is great, which is fine. I'm not knocking it. Why? Because it's good to know how to make and how to round up. That's not a problem. Abacus, we don't need to do it. Abacus is its own benefits, right? It's not the end all. I'm not saying it's the end all, but it does provide a really solid foundation. And we build on this. And then from here, when we know our addition and subtraction, then we can do multiplication. Because multiplication is just, bigger numbers, but faster addition. But we still do add addition to the numbers. So the answer is 54. The answer here is 103. Yeah. Here, sorry, we were counting. So this is 4, and then this is 5. Anytime the beads are touching the horizontal bar, this is 5. After 5, we have 6, 7, 8, 9. And after 9, this is 10. 10. So we have 0 and 1. Because we have that, we understand we have columns. These columns are place values. Oh, I should do that. These columns are place values. So this is 10. This over here says $7.25. So 2 and a 5. Because I'm talking about the decimal. The decimal sits between the ones and the tenths. So when we are looking at it, we can do $97.25. But we pay attention, right? If you notice, this 5 is down and this 5 is up. So you have to pay attention to detail. What is being counted and what is being not counted. So these are not counted because they're not touching the horizontal bar. These are also not counted because these are not touching the horizontal bar. These are counted because these are touching the horizontal bar. So when we count 1, 2, 3, 4, and then 5, 6, 7, 8, 9, and then 10. 1, 0, 11, 12, 13, 14, and then 15. After 15 is 16, 26, 36. So we can start counting by tens. 30, and then 46, 56. And then after tens, we have our hundreds. So we have 556, 656, 756. Make sense? But see, the thing is I think we underestimate adding and subtracting. And we have a lot of, like, in Abacus there's a lot of two-step equations. And they just build on top of each other. But I mean, like, you know, you could do the strategy. Well, I know that if I add 1 here, it's 50. And I know because I added the 1 here, I have to take away the 1. I don't know this strategy. I'm just thinking ahead, right? And this is an easier number to worry about. Okay, then that's 54. You could do that too. Same thing. It just depends on what your strategy is. Mine happens to be Abacus. Mine is an Abacus methodology. And so if you want to learn how to use the Abacus with the bigger numbers, so like we had bigger numbers. But then the thing is as the numbers get bigger, there's multiple ways of solidifying our two-step equations. So yes, I was thinking about the previous comment. Yeah, when you're doing Abacus, when you're adding and subtracting, if you can keep the algebra in your head, it was funny. My child took algebra, and he's like, how come I know algebra, but I was never taught algebra? I'm like, it's because Abacus leverages a lot about algebra. And if you notice, we did the two-step equation, right? It's the same thing with isolating the variable. We do x plus 2 is equal to 10. We know we're trying to make a 10. Oh, sorry. We know we're trying to make a 10. Or what we're trying to do is we're trying to make a 5, right? What are the two ways to make a 5? And so this is our x. So yeah, it's a little library of Abacus, algebra formulas. Yeah, that's a really good analogy. Yeah. Anybody have any more questions? If not, we're going to continue on. So then we're going to go into more adding and subtracting, if that's okay. But then there's the book that I was creating because I was thinking that the kids are young. And so the way I have it is there's like these cats in a tree, because sometimes it's difficult to understand why we're adding the 5. So I have it where we're talking about 5 cats in a tree. There's always going to be 5 cats in a tree. This tree is the 5. This is the tree. So there's always going to be 5 cats. So the question is 2. So if I add 2, now I need to add 3. There's not enough beads to add the 3. So again, this is another conversation, right? There's not enough beads to add the 3. What are we going to do? Oh my God. We're going to do, okay, so what happens? We go to the cats in the tree. I wiggle my fingers. We go to the cats in the tree. We grab 3 cats. What happens? 2 cats run away. So 2 cats run away. I add the 5, which is the cats in the tree. I add the 3 cats, but then 2 cats run away, and my answer is 5. So either we memorize this, right? 2 plus 3 is equal to 5, or we understand it and we can utilize it. So when our next question is, let's say 4. 4 plus 3. Again, go to the cats in the tree. I'm the 5, and then I grab 3 cats, and 2 cats run away. 2 cats run away. So my answer is 7. And again, it goes into, it scales. It scales to bigger numbers, and it scales when it gets, the numbers become, it scales when the numbers become bigger, or there's more of it. So this is easy to show, but, hey Alma! Thank you for the hearts. So it's easy to show, excuse me. It's easy to show, but we have to get to the point where, for us, it's easy, right? But what I'm trying to do is I'm trying to show the benefits of using the abacus. All right. Anybody have any questions? Whew, I had a coughing fit. Whoa, that was horrible. Okay, but now, I got tuberculosis. I'm so sorry. Shared my life. Thank you. if you got tuberculosis and you share my life, does the sharing of my life also get tuberculosis? I don't know if that was a thing. Okay, sorry. So this one specifically, we talk about the add-ins. As we talk about the add-ins, we want to make sure, again, we want to make sure we are looking at the number we're adding. Now, sometimes, because as the question arises, we don't need to use the cats in the tree. Why? So if I have 1, the question is, if I have 1, can I add 2? Yes, I can add 2, so I don't need to go to the cats. So you don't need to overextend or over add, right? If you can do it, that's great. If you can't do it, then you go into other ways, like, how else can I do it? So I think it's nice to be able to, I think this helps to think outside the box. It's not necessarily thinking in the box, right? So Abacus gives you a framework and gives you, like, here's some Lego pieces and figure out what you want to make out of it. And so, do we need to make anything? No. We have it all there, so we just need to add it. Same thing with the 2. We add the 2, and then there's another 2. Okay, fine. But then we get to here, or here, right? We have the 4. We need to add the 2. There's not enough to add the 2, so now we look at our resources and we see, well, what can I do? Plus the 5, go to the cats in the tree, grab 2 cats, 3 cats run away. So 3 cats run away. So my answer is 6. So now I just made my 2 versatile. I made my 2 work for me. I made the 2 be able to utilize. And then we can go into bigger numbers. But knowing the fundamentals, understand the fundamentals before you can go on to bigger numbers. Does that make sense? So 1 doesn't have a lot of questions. 1, it's either going to be a +4 or it's a +9. That's it. Why? Because if I do 1 plus 1, there's enough beads. But the problem is when you get to 4, I have 4 and I want to add the 1. To add the 1, there's not enough. So I have to go to the cats in the tree. And I grab 4 cats. I'm sorry, I grab 1 cat. 4 cats run away. So 4 cats are taken away. And that's the only question we have. It is what it is. But it's easy to see, how to do it. So let's do 1 plus 9, right? Same thing. Because I have the 5 here, I cannot add a 5. So what's another way to add a 1? Plus the 10, take away the 9. That's the only question we can do for adding the 1 when it comes to formulas. That's it. But you know what? Interesting though, it does get used more often than you think. Why? So confused. Oh, hey, toes, knees, eye. Sorry, let me think about my thought. Let me complete my thought. So the 1 is actually easy, but it's used more often than you think it is, which is funny. Okay, toes, knees. Okay, what we're going to do, hey, heart. Okay, what we're going to do is we're going to count 1, 2, 3, 4. After 4, this, if toes, knees sticks around, it'll make sense. Yes, but that's, okay, so 4. Anytime the beads are touching the horizontal bar, this is the horizontal bar. We want to use the horizontal bar to track our numbers, to track our beads. So as the beads touch the horizontal bar, this is being tracked. We have 5. The top bead will always have a value of 5 no matter what. So we have 5, 6. So we notice we have 5 plus 1 is 6. And then 7. 5 plus 2, because I have 2 beads here, 5 plus 2 is 7, and this is 8. 5 plus 3 is 8, and then 9. 5 plus 4 is 9. So after 9, what's after 9? Well, it's 10. This is 10. Just as how we write 10, just like how we write it. 10, 1, 0. We have our tens place and we have our ones place. So now Abacus talks about the place value. I don't know if toes and knees is still here, but let me know if this makes sense. Add the 5 minus, add the 5 minus the 4 will add the 1. Yes. Oh, hey, Esme. Yeah. Okay. We're going to continue to count. So we have, this is going to be 11, and then this is 12. So add the 5 minus the 4 will add the 1. Yes. Yes. Nickname, but to me, that's backwards. Because what I want to do is I want to isolate the variable. I want to add the 1. And then how do I add my 1 is where I do my stuff. So I'll be take the 5 and then add the 4. Or minus the 4. Yeah. So this is 12. This is 17. Why? Because the top beat always has a value of 5. So we have 5, 6, 7. So when we look at it, this is 17. 1 and a 7. This will be 20, 27. How do I know? 2, 7. And they go by place values. So just like we have place values, in our columns, we have our ones, our tens, our hundreds, our thousands, and our 10,000. Oh, that doesn't make sense. There we go. So our ones, our tens, our hundreds, our thousands, and our 10,000. Thank you. Thank you for the heart me, Amma. So I don't know if toes, knees is still here, but let me know if you're still here. But Esme, does that, okay, good. So when we look at it, this is always going to be 9. Each column has 9. So this is 9, that's 9, this is 9. But now it depends on what number it is. This is 99,927. So it all depends on the columns. Okay. Hey, Goo. Okay. We're okay? Does that make sense? Okay. So add the, so if we're so if we're doing this and we add the 1, right? We want to add 1. We add the 5. So the other way to look at it too, nickname, the other way to look at it too would be, how do you balance the equation? When we look at it, we have 4. We're looking for the 4, and we have it to make it a 5. What we need to do to balance the equation, we have to minus the 1, right? You could do the same thing. It's just like doing with the x. If we're looking for the 1 and I need to make a 5, how do I balance the equation? You could think of it that way. Minus the 4. You could think of it that way. I don't. I'm trying to find other ways to explain this, only because why? Because if I can explain it different ways, then maybe somebody else will be able to understand it. You know what I mean? So, and that's why it's great to have the questions, because yeah, I did it. Yeah. Yeah. When I do it, it's not necessarily backwards, it's how you think. But when I do it, I'm thinking, this is what I'm trying to do. I'm trying to add the 1. So what am I trying to do? You know what I mean? That's why somebody asked me if English was my first language, and I'm like, yeah. But I think it's because when we do it this way, it's different, because in mainstream math we do it the other way. In mainstream math, we do 5 minus 1 is equal to 4. But what it is we're not trying to find this. We're trying to find this. So I think it matters what we're trying to do here. It was really interesting. That makes sense. Yeah. So it's different. It's just different because the target is the add-in. The add-in that we're trying to do is this. Hey, is that an M? I don't know if that's an M. I'm sorry. Okay. I was trying to look at somebody's name, and they have that calligraphy words, and it's just difficult to see. All right. So does that make sense? So, okay, 1. The reason why 1 is so difficult, it's not difficult. It's very versatile if you really think about it. Because we can say 41, right, 44, 40, 41, 44. So this is the same number, right? If we did 44 plus what? Plus 67. Let's do that. So we do 44 plus 67. So we're going to do 6 There's not enough beads to add the 6. What do? Well, plus the 6 is plus the 10 minus the 4. So we're going to plus the 10. So we're here. We're going to add the 6. So we're going to plus the 10, take away the 4. And then what do we do here? Plus 7. Plus 7 is this. Plus the 10 minus the 3. So we plus the 10 and then take away the 3. That's it. So we just used a bunch of plus 10 formulas. But notice we did a carry over. We're carry over. In Abacus, we don't call it carrying over. We just call it plus 10s minus 10s. But in mainstream math, we call it carryover. We call it borrowing. What else do we call it? We call it regrouping. And we call it grouping. I don't know what else we call it. These are the only terminologies I know. And if you notice, I went from left to right. I went from left and then to right. You could do right to left. That's not a problem. It's just you got to keep track with your digits. Yeah? Are we okay? Make sense? Esme, do you have any other questions? You don't know that 4. Ha ha ha. Plus 10s. Yes, okay. So plus 10s. No questions? Come on. Come on. How can there be no questions? Okay. So plus 10s. Yes. So this is the plus 10s. And it's the same thing. Hey, Sandra. And it's still the same thing, right? We need to know how to plus the 9. Plus the 9 is plus the 10 minus the 1. Well, when does that happen? It happens all the time. So if we did 3 plus 9, you'll see that there's a pattern. How does the abacus work? Hey, Sandra, hold on just a minute. Plus the 9 is plus the 10 minus the 1. Plus the 10 minus the 1. So my answer is 12. All right, so Sandra, the first thing we're going to do is we're going to understand how to count. When we learn how to count, then we can start going into place values. In the abacus, we actually talk about place values. So we have 2. This is 2. 1, 2. Anytime the beads are touching the horizontal bar, this is considered counted. These beads are considered counted. So this is 2. We have 3, 4. So this is 4. These are all 4s. If I did this, all of this would be 4. Now, this is 0, but this is 4. Notice that these beads are touching the horizontal bar. When the beads are touching the horizontal bar, we're counting it. So now you might be thinking, well, what happened to 5? 5 is the top bead. 5 will always have, the top bead will always have a value of 5 no matter what. Because this is 5, we can add 6. After 6 is 7. After 7 is 8. So we have 5 and 3. 5 plus 3 is 8. And then we have 9. 5 plus 4 is 9. So we have 9. This is 9. But this is 99. So now we have to start paying attention to our place values. We have place values. Each column is a digit. Each column is a place value. We have our 1s, our 10s, our 100s, our 1000s, and our 10,000s. So we could do more. Yeah. Okay, good. So that makes sense. But that's all that it is, really. So now you might be wondering, well, why am I here? If you notice, I have an indicator. This indicator tells me that this is my home. This is my ones place. You could choose this, but I chose this because I wanted to have more numbers. You could choose this. It'd be the same. But if you, depending on what you choose, the next column over, which is here, right, will be the tenths. So this is where my decimal lies. So I have my 99. This would be 99.1 or $99.01, right? So this is where the decimal plays. Just like how we write it. Abacus mimics the way we write. Anybody have any questions? I don't know what NGL is. Now I know how it works. Yeah. quite cool NGL. I don't know what NGL means. I'm not young to understand that. Thanks so much. Not a problem. So what we're going to do. No, oh, not going to lie. Thank you. Thank you. Okay. Thank you so much. Okay. So we understand how to read the abacus. Once we understand how to read the abacus, now we can do. You're good. After we understand how to read the abacus, we're going to do some adding and subtracting. We can actually do multiplication and division, but the first thing we need to do is understand how to add. So I already started to show you how to do some simple adding. If you notice, when we do 8, it's 5 plus 3. You can do 8 like 6 plus 2. You could do that too. Or when we do 8, we do 9, take away 1. But notice, in the abacus world, we don't focus. Hail Odyssey! in abacus, we don't focus on the result. I focus on the result just now, but we don't focus on the result. What we do focus on is the add-in itself. Now, what does that mean? When we go through abacus, each number we add is going to have a different behavior. That's how that works. So if you notice, we have 4. Let me do 4. Let me do 2. Let me do 4. So we had 4. Four doesn't have a lot of numbers. We have 4. So if I have 5 and then add the 4, that's it. Now we just added the 4. However, it's different. We want to add 4. Let's say I want to add 4 to this. Not this. That's a little bit of it. There's a little bit. Why? Because there's not enough beats to add the 4. In school, and I was mentioning this before, in school, we're teaching our children, and I don't know if I don't know how young everybody is, but in school, I'm not sure if they taught you how to make a 5. Now, the reason why is because we want to utilize this 5 up here. To make a 5, we do 1 plus 4 is equal to 5. This is very similar. What I'm going to show you is very similar to algebra. Let me replace this with an x. So now what we're going to do is we're going to isolate this variable. Why? Because the question is 4 plus 4. We do not memorize our doubles. What we do memorize is our equations. We memorize our formulas. That's what this is called. So what's going to happen is I'm going to isolate this variable. When I isolate this variable, this is the variable I'm going to isolate. This is the variable I'm going to isolate. I got to move the 1 over here. So I'm going to rewrite it. X is equal to 5 minus 1. Does that make sense? So now let's replace this x to a 4. So my formula is actually 5 minus 1. If I want to add the 4, this is the conversation we're having. If I want to add the 4, all I need to do is add the 5, take away the 1. Now what I'm going to do is I'm going to substitute into here. If you notice, I'm going to add the 5, and I take away the 1. And you're like, wait a minute, that looks too complicated. We already did it. I was like, no. We don't memorize doubles. Why? Because now we understand how to do this add-in. Now it becomes more versatile. So let's say we did 2. 2 plus 4. Same thing. I want to add the 2. There's not enough beats to add the 4. What do? Well, we already know this because we knew it from here. So now what we're doing is we're building. We're building our information. We're what's it called? Deep diving, right? We're deep diving our information. So what we're going to do is we're going to substitute this. Plus the 4 is plus the 5 minus the 1. And my answer is 6. Does that make sense? Yeah. And it's the same thing with when we do the plus 10s. When we do the carryover. Hey, sorry. Makes sense. Okay, good, Otter. Yeah. Excuse me. Let me know if you have any questions. But we can continue on. I mean, I think we underestimate the value of adding. And adding it gets complicated quick in the abacus world because we add a lot of dividends. But what we need to do is we need to make sure we understand the add-ins itself. We don't we need to divorce from the result. We need to marry the process. Alma, did you get that? We need to marry the process. That's one of the things that they were talking about with content creators. Don't just divorce the results and marry the process. I'm like, that's a really good saying. And that's what Abacus does. Abacus mimics life. It's not about the goal, it's about the journey. I cracked myself up. Hey, TK, hey, Professor. So that's what we're doing here is we're understanding what the process is. As we understand the process, then it's easy to grab the result. But we all still need to do that. Not even knowing the answer, you still have to. So even knowing the answer, you still have to know how to move the pieces, the formula. Exactly. How are you doing? I'm doing very well, thank you. I had a little bit of coughing fit, but I'm over that. Oh, I'm really curious. Why do you do the math from right to left and not left to right? We do. You know, this. It's because we're using this, so we need to. Because we want to isolate this in algebra, right? Don't we have our x on one side? So that's the other thing. Like I guess we could do it the other way. 5 minus 1 is equal to x. You could do it that way. But to me, now we're trying to say, okay, if I take away 5 and if I take away the 5 minus the 1, then I get the answer 4. Whereas if I do it the other way, if I do x is equal to 5 minus 1, I'm going to take this x, I'm going to substitute this. I don't know. In Abacus world, this is how we do it. That's a really interesting thought. Yeah. Yeah, I don't know. There's something to this. I would have to think about it some more. I'm not sure. But when we do our adding, we go from left to right. But when we talk about our formulas, we want to isolate the variable. When we isolate the variable, it's always going to be on the left side because we're utilizing it. I don't know. I have to think about that one. So like here, when we isolate the variable, we want to use the 4 or we want to use the 1. And then we take this and we substitute it. I don't know. Maybe? Or maybe it's I don't know. I have to think about that one. I don't know if that made sense. Okay. So the next thing we're going to do is, so we did the 5. We're okay with 5. We can go into tens. And the tens is relatively the same. The concept's still the same. On the abacus, you start from right also. Oh, you know why? Because it's just easier to see. Because this is my ones. And it's just, I could say my thousands. If I did 3,468, I do 3,468. You could do that. Or you could go backwards. If I know it's 6, I know if it's 8, 6, 3, 4. It doesn't matter. But when I read it, it would always be 4,368. The reason why I would go from here to here, because I don't know how long my question is, how long my digits are. Because when you start getting into like when you do 400, I guess it's easy to do it this way. You could do 439. You could do it. I think I do it this way just so I know that I make sure that I'm at the ones place. Because I want to line up my ones. I think that's why I do it. I think that's why I do it. Because I want to make sure my ones line up to the dot. When you get to bigger numbers, so this is a 23 column abacus. When you get to bigger numbers, it can get really confusing really quick. So I think if you started off with the ones and then you just place it all there, you're going to end up in one of these dots. But if you start over here, like if you did like 53,000, I'm like, okay, where's 53 going to go? 53,000. I was like, okay, well, I know this is the thousands, so I'll have my 3 here. So it'll be 50, 53,000. So that's what I think. That's how I'm thinking it. I don't know how everybody else does it, but that's how I do it. And I think that's why I do it. So I make sure that my ones is in the dot that needs to be. Right. No, those are very good questions. Thank you. Okay. Hello, Agent Meerkat. All right. What are we doing? Are we have any more questions? Any questions? Okay. What I'm going to do is I'm going to do a boom, boom, boom. Plus tens. We're going to do plus tens. So this is also another fundamental formula. In one of these is we need to understand, same thing, the concept is making it 10. 9 plus 1 is equal to 10. And it's the same thing, we're going to move and isolate a variable. So what's going to happen is, when I want to add the 9, I'm going to substitute this right here. That's what I'm going to do. So when I add the 9, what's going to happen? My question is 9 plus 9. So again, we don't memorize our doubles. What we do memorize is our formula. So we have our 9 and we take away and we add another 9. When we add a 9, we need to plus the 10 minus the 1. So we plus the 10 minus the 1. And then you'll see that there is a pattern. Anytime I want to add the 9, I have to plus the 10 minus the 1. So my answer is 18. I had a little asteroid thing here. The reason why was to help the kids to understand that they're going to take away 9 and then they have the 1. Or they use the 9 and then there's 1 that gets floated out. So thank you for the hearts. Right. Anybody have any questions? If not, we're going to continue on with the book. So here's the other question. 4 plus 9. 9 is an easy number to find questions. And that's why I always start from 9 first. I don't start from 1 because you don't use 1 very often. If you look, if I added 1, there's enough beads to add the 1. So it's not... So the concept I was trying to show was to plus the 10. Adding the 10 only means you're going to the next column over. It doesn't matter if it's 40 plus 90. It'd be 40 plus 90. Plus 90 is here. I want to add the 9. So Abacus breaks it down into manageable chunks. Plus the 9 is plus the 10 minus the 1. I don't say plus the 100 minus the 10. Then it gets confusing. Break it down to its fundamental, simplest form. I guess you could say, like, in multiplication, you'd call it the lowest common denominator, or the most, yeah, right, the most common denominator, or the lowest factor, something like that. So in Abacus, we do the same thing. We don't say big numbers because there's no point. It's just redundant. And then it gets confusing because if you say add 100, are you talking about the next column over, or are you talking about 100? You know what I mean? So that's why you bring it down to its fundamental, which is plus the 10 minus the 1. So we plus the 10. I'm only going to the next column over. And then we add the 1. I'm sorry, we take away the 1. Yeah. Hey, Ethan. Anybody have any questions? So when we talk about it, we do this one. We could do 3. 3 is also a good number. Because why? Because when we want to add the 9, it's plus the 10, take away the 1. So this is a lot about just showing the different scenarios and just trying to make sure we understand how things go. Mainstream math doesn't do that. Mainstream math just gives you a bunch of numbers and be like, have at it, you just add it. Whereas in Abacus, there's a framework, there's a formula, there's a set pathway that everything goes. So here, again, I want to add the 9. I'm going to plus the 10, take away the 1. And my answer is 12. So you see that it's very systematic. And because it's systematic, then the kids will see, hey, Pineapple, welcome back. It's very systematic. So if you notice, we have the next one, which is 2. I noticed there's this one, I was looking at my kids' old like timed test stuff, and it was interesting how they just give you a bunch of numbers and you're just trying to figure it all out. But in Abacus, it's very specific. Um, oh, is it here? I don't know if it's here. Um, oh, I didn't add it. Okay, but in Abacus, it's very specific. So if you notice, there's these questions over here. This is what we call simple. That means that do we have enough beads? Yes. So if we have enough beads, we're going to add. Then the next one is at making a 5. Do we have enough beads to add the 5? That means that if I have 4, I want to add the 3. So notice we have the add-in is 3. It goes from simple to plus the 5, plus to go back to simple, excuse me, and then here we do plus tens. So it's very difficult to be able to tell the kids just kind of, just add. Whereas in Abacus, there's a set formula, there's a set framework, there's a pattern, and this is the pattern. So all of these questions over here is adding the 10. This is our two-step equation, which I kind of like jumped everybody forward. This is the two-step equation. And then again, we go back to our plus tens. And then this up here is only the simple. So you'll notice the 5 is kind of easy because it's either plus a simple 5, so we plus 1 and then add the 5. And then here we have plus 2 and then add the 5. Notice that how we have enough beads. Now, when we go here, 5 plus 5. Well, there's not enough beads to add the 5. What do? Plus the 10, take away the 5. And then let's jump to here, 7. 7, we have 7, and we want to add the 5. Do we have enough? No, we need to plus the 10, take away the 5. So looking at this is about understanding the pattern. And this is the pattern. And it's solidifying the pattern. Because we have the addition, there is the subtraction. Subtraction is the same way. This is the take away the 5. This is simple stuff. And then this is the minus the tens. Yeah, thank you so much for liking the live, Pineapple. Anybody have any questions? Questions? Anybody? Bueller? All right. That's what that is. Okay, so then that's why this specific book is all about the add-ins of adding the 10. When we do, why don't you just add another blue one to make it 10? Because if I did this and this, that would be 55. Can you show 14 minus 5? Okay, yeah, let's do that. So, sorry, did that make sense? That's not 10. This is 10. That's 10. Before I continue, unless you had a Chinese abacus, then this would be 10. It would be 5 and then plus another 5. That would be 10. But that's different, right? So all the top bead will always be 5. And we have to pay attention to the place value. Each column is a place value. So if I did this and I did this, the place value of this is tens. So this is a 5 and then this is a 5. So that means this is 55. Okay, so the question is 14 minus 5. I didn't do that. Yeah, not a problem. That's a really good question. And it's just interesting how it's just interesting how people look at things. And it's so true, right? So as long as you ask the questions, we can have a feedback on it. So here's the question, 14 take away 5. Well, I'm going to use this one. I'm going to add 14. I'm going to go here because it's not a lot. Now the question is minus the 5. We know how to minus the 5. Minus the 5 is minus the 10 plus the 5. Again, it's just like if we had So what do? We minus the 5. We minus the 10. That means we take away, we borrow the 10. We take away the 5. We take away the 10. We take away the 10 because we're borrowing. We take away the 10, but then we need to add the 5. So on the abacus, we just need to add the 5. My answer is 9. Let's see. We can do another one. We could do... We could do... Okay, we'll do this one. We'll do 15. We'll do 15, take away 8. We could do that. So same thing. How do we minus the 8? Minus the 8. What is the formula to minus the 8? It's very similar to the 5. How do we take away the 8? If we don't have enough beads, we have 1 and 5. If we don't have enough beads to minus the 8, what do we do? Misguided mistletoe. Yes, thank you. It's backwards now. Minus the 8 is equal to minus the 10 plus the 2. We've been working a lot on adding. Now we have to take away. So when we look at it, we want to do minus 8 minus 2 is equal to minus 10. When we do that, we can flip it over. So we have to make sure that we're taking it away. So this is where understanding your operators is critical. So we minus the 10. Hold, please. I have to verify that I'm still here. And there we go. All right. We minus the 10. What we did, we took away the 10. Now, is there enough beads to add the 2? Yes, there is enough beads to add the 2. All I got to do is add the 2. There we go. I always count up to the higher number for the takeaways. So 15 minus 8, I would... You could do that. You could do that. But that's misguided mistletoe. You could do that. It's not a problem. If that's a path that you like to do, then that's, it is what it is. I'm just showing an abacus way of doing it. So what this means that we understand how to add and we know how to subtract. There's a bunch of formulas that we need to know. So let's say we did I do it differently. I'm really interested. I see, misguided mistletoe. Yes, thank you. I appreciate that. Thank you for the comment. Thank you for the compliment. But it's interesting, right? Because when we know the fundamentals, then it's easy to fit. So I'm not sure if you were here for that. Using the abacus, using the formulas for an abacus, using the abacus formulas, it's like knitting. How do they all fit in? Which is really interesting. So if you notice we have a plus 10, well, when we want to add the 10, it's the same thing as adding a 1. There's 2 ways to add the 1. You can either add the 1 with a plus 5, or you can add the 1 with a plus 10. So we cannot forget that. Let's do another one. So this one was 7. Yeah. What else? We're going to do here's a number. We'll do 16 take away 4. Right? 16 take away 4. If we have 16 and we want to take away 4. This, again, it's just to practice, right? It's to practice the minus because we don't subtract a lot. I mean, I haven't been subtracting a lot in my lives. And so I think we need to practice that because now the question is how do I take away 6? Sorry, how do I take away 4? Minus the 4 is equal to minus the 5 plus the 1. Whoa, I didn't do that right. There we go. Minus the 5. Can I take away the 5? Yes, because the idea is I want to take away the 4. So I needed minus the 5 plus the 1. So I take away the 5 and I add the 1. Any other questions? We can continue on. Oh, my answer. What's my answer? It's 12. Yeah. And it's interesting on how there's patterns, and I didn't realize that what the patterns are. I mean, we could do the same thing with so that's the adding, and we could do the same thing with subtraction. Subtraction has the same set of patterns. I just got to figure out what the patterns are for multiplication and division. I haven't figured out that pattern yet. Anyways, so let's do another one. We can do 17 minus 3. 17 minus 3. So we make the 17, 1 and 7. That's not 7, that's 7. Right? So we want to take away the 3. How do we take away the 3? The first thing we need to do is ask, can we take away the 5? Yes, we can take away the 5. So, because we can take away the 5, minus the 3 is equal to minus the 5 plus the 2. So I want to minus the 5 and then plus the 2. So my answer becomes 14. Yeah. It's interesting. It's interesting to be counting up and to be counting on. It would take a lot more time. But I could see that that is a strategy. I guess the other way Abacus does is it shortcuts a few strategies, right? So because we know this, we've ingrained this into our brain, then we'll be able to manipulate it. So, yeah, I mean, I get some people saying, it's complicated. It's complicated if you don't want to understand. But I think it is enough to explain. I think it's enough, if you stick with it, obviously. If you don't stick with it, then it is what it is. Okay, so we can do another one. Let's do another one. We could do 16. Let's do it. You know what? Let's do a bigger number. Let's do a bigger number. Where is it? Okay. No, that's not what I want. There we go. There we go. 75 minus 7. Same thing, right? 75 minus 7. So we put 75, 75. Take away 7. How do we take away 7? Well, minus the 7 is what? Minus the 7 is equal to minus the 10 plus the 3. So if I want to take away the 7, I have to take away the 10 minus the 3. See, now it doesn't matter, right? So now we do minus the 10 and add the 3. So my answer is 68. Anybody have any questions? Are we okay? Are we good? We're all very quiet right now. Okay. Oops. Do we want to do more? Good. Okay. Do we want to do more subtraction? Are we continuing on? Or do we want to go something different? We could do more. Okay. Okay. You know what? We'll do 73. 63. We'll do 63. 63 minus 5. So notice minus 5, right? Minus 5. This is a minus 5, but now we're in bigger. What do? 63. Again, it's all about focusing what we have and what we don't have. Okay, good. I'll work on that. Do more. Okay, not a problem. So we did 63 minus, so we have to take away the 5. Take away the 5, just as we did up here. Minus the 10 plus the 5. So what are we going to do? Minus the 10 minus the 10 plus the 5. So we minus the 10 and we add the 5. So the answer is 58. So let's do another one. Okay, let's see how big this question is. We'll do over here. I'm going to do, let's do green. Okay, so the question is 34/7 minus 89. Okay, let's see how many questions, how many step problems we have on this one. 3, 4, 7. Take away 80, 9. Take away 8. How do I take away 8? Take away 8 is equal to minus the 10 plus the 2. All right, what are we doing? We're going to minus the 10. We're going to add the 2. So we're going to minus the 10, add the 2. Can we add the 2? No. So now this is a two-step equation. How do we add the 2? Plus 2 is equal to plus 5 minus 3. So I need to plus the 5 and take away the 3. Now we need to take away the 9. Take away the 9. How do we take away the 9? Take away the 9 is minus the 10 plus the 1. So this is the 9 we're going to take away. We're going to take away 9 from this column. When we take away 9, it's minus the 10 plus the 1. Minus the 10 plus the 1. That wasn't too bad. So my answer is, what's my answer? What does that say? Do we know how to read the abacus? Oh, thank you, Otter. 258. Yes, Amma. 258. Yeah. Any more questions? Any more questions? Give me a question and we'll do it. We'll see how complicated it can get. This other person gave me a really complicated one and then she was like, oh, you lost me. I was like, well, okay. But we can't. Can you show the whole process again? Yeah. So the question is 347. So the first thing I'm going to do is add 8. So I'm going to add the 8. I'm going to add the 8 on the tens area. But to add the 8, I need to minus the 10 plus the 2. So I'm going to take away the 10 first. I'm going to add the 2. I cannot add the 2. So what do? I need to, in my column, plus the 5, take away the 3. Why add 8? Because that's the question. Oh, not add 8. I subtract the 8. I want to subtract the 8. I'm sorry. I meant minus 8. So this is a minus 10. Minus 10. So minus 8 is equal to minus 10 plus 2. Why add 2? Because that's the formula. 8. So it's 8 minus 2 equals to minus 10. And then we isolate this variable because we're taking away the 8. We need to move this over here. So then we have to minus the 8 is equal to minus 10 plus 2. And then we have to take away the 9. To take away the 9, there's not enough. Minus 9 is equal to minus 10 plus 1. I minus the 10. And then I add the 1. Did I misspoke? Okay. So then my answer is 258. Yeah. Yeah, sometimes I misspeak. Let me have another question. All clear for now. Okay, great. Great. Oh, that's the question. Are we going to the gym? Okay. Oh, great, Amma. Thank you. So let me get a new page. Okay, let's see how complicated. Okay. Go now. Okay. This will be my last question. So 4,739 minus 749. Okay, this is going to be a little bit. I already can tell. How do I tell? Because this is now a 0. When we talk about it, let me do one more question, then we'll go. We do it this way, right? So we talk about the 7. So we did 4, nope, 4, 7, 3, 9. We can take away the 7, not a problem. We take away the 7. The problem comes, now we need to take away the 4. There's not enough beats to take away the 4. So what are we going to do? Let's move it out a little bit. So minus the 4, can we take away the 5? No. So this is the step that I would talk about, right? These are the questions I would keep asking. So if I can't take away the 4, I cannot take away the 5, what do I do? Well, I want to minus the 10. There's no minus 10. No, because there's no 5 to take away. So we can't take away the 5. So the first thing, so then if we want to minus this 4, because that's where we're at now, minus the 4 is minus the 10 plus the 6. But now this gets more. Why? Because we don't have any beats to take away the 10. We don't have any beats to take away the 1. How can we do it? What's another way to take away the 10? So I'm putting my finger here because what we're going to do is we're going to take away the 10 here and we're going to add the 6 here. But there's no beats to take away 10. What's another way to take away the 10? Take away the 10. We have this. Minus the 1 is again minus the 10 again and then plus the 9. So what do? We minus the 10 plus the 9. So this is where we borrow. We minus the 10 and then add the 9 and then add the 6. Now we're at the take away the 9 and we just take away the 9. So my answer is 399. 3,990. But it's a little bit because right here, does that make sense? Because there's a 0 here. Let's take it back. So if I did 403, where's my 3? And there, I've lost you. Yeah. So let's go back. Maybe if I can write it out, maybe that will be better. So right now I have 403. So I'm here. I finished this, right? I finished taking away the 9. So I'm going to rewrite it. I'm going to do 4. I'm going to rewrite this. 0, 3, 9 minus. This is what we have. Okay? This is what we have. Let's see if I can illustrate. Let me see if I can do it step by step. Okay, so we have minus the 10. But notice, so minus the 10, there's a 0 here. So what do? In old math, what do? We cross that out and make it a 3. Why not rewrite? You could. I could. You want to take away the 10, we could take away the 10. Take away the 9. But then we have to remember we're here. So we could do 4. I'm sorry. I'm going to change. So we do 4030. So the question is 40 minus, right? So that's where we're at. Yeah, we could do that. That's not a problem. Because we already take away this. So we already took away that. Okay, so we're okay? This is where it gets tricky. Okay, this is where it gets tricky. Why? Just as we have the 0 here, in old math, right? In old math, what do? We borrowed. Take from here is 3. Same thing. But we have a formula to go with it. This, what we need to do is minus the 10 plus the 6. The 0 becomes a 10. Yeah. But Abacus doesn't do 10. Abacus does 9. So this is why we have 9 here. Ah, yeah, because it becomes 10. And then we take away the 9, and then we have, that becomes 10. And then this becomes thing. Because there's not enough. So this becomes, because this becomes a 10, we cross that out, it becomes 9. So now we're borrowing, right? So in here, what we're doing is we're moving the 10 over to be here. So there's 13 here, right? But in Abacus, we don't have 13. We have only one column. So that's why, that's the old way, yeah. So the old way is we would have to take the 10 and do this. But because we're talking about Abacus, we don't have any beads to add the 10, but we have the formulas. We have to, minus the 1 is equal to minus the 10 plus the 1. Minus the 10 plus the 9. I'm sorry, minus the 10 plus the 9. Then I have enough, right? That is what we did here. That's the minus 10. So we just answered this. So we want to plus take away the 4. Take away the 4 is minus the 10. So what we're doing is we're filling this first. Minus the 10 plus the 9. And then we take away the 6. So we take away the 6. I'm sorry, we add the 6. So we add the 6. The old way has 2 digits, but Abacus doesn't have 2 digits. So we have to work with the columns that we have. So let's go back. So we have 4030 minus 40. This is minus 4 is equal to minus 10 plus 6. This minus 10 cannot be here. We have to take away 10 from here. That's what we got to do. But to take away the 10, it's just like minus 1. Minus 1 is equal to minus the 10 plus 9. So we got to minus the 10 here, and then add the 9. I don't know if that was confusing. Maybe if I just did like stacks, I could stack it. Maybe that would be a good visual. So that would be add the 9 minus the 10. So we take away the 10 from here, add the 9, and then then we add the 6. But that's the formula. That's interesting. That's a very interesting way of thinking of it. I don't know if that made sense. It's one way to explain it to old people. It's another way to get the kids to just do it. Because they can see it. They know that if I need to minus the 10, they use the formula. But because we know many different ways, it can get confusing. So like this one, right? Like we know we're taking away the 10, so we move the 10s over so we can take it. So that's what they do is they break open, they do regrouping and grouping with this. So that's interesting. Yeah. But because Abacus only has 9, let's look at this one again when you have more time. Yeah. Yeah, the problem is it's the two-step equation, right? The two-step equation is what what we always bypass, and we kind of like, we shouldn't. Because the idea here is, how do we supplement this? But yeah, okay, I'll take a note of this. There's many of this, right? Because what we got to do is we got to accommodate the zeros. So it's the same thing with like 100 minus 1. It's the same thing because it's 1,000. 1, 2, 3. So it's 1,000 minus the 1. Minus the 1. Minus the 1 is minus the 10 plus the 9. So we just got to repeat it. Minus the 10 plus the 9. Minus the 10. Minus 1. Minus 1 is minus the 10 plus the 9. So we do it again. And then we do it again. But it depends on how often we do it. Minus the 10 plus the 9. We can't do it. Minus the 10 plus the 9. Plus the 9 minus the 10. So my answer is 999. How do I know to stop? Because I already took away the 10. So I minus the 10 and I plus the 9. As an adult, I do so many variations in my head. So learning this is very new. Yeah, that's the one thing. Like, we have so many, yes, you're right. We have so many ways of doing this. It just, to be strictly to do abacus math, the kids don't get confused because they're taught one way, but they're given many strategies. And I think because of all the strategies we give them, it gets really confusing because they're like, I don't know which one to use. Whereas in abacus, it's really specific. So Alma, did that make sense about the 1,000 minus 1? But see, that's the thing. Minus 1 take away minus the 10 plus the 9 is a very common formula. So we do it again. And I want to take away the 1. How do I take away the 1? Take away the 1 is minus the 10 plus the 9. Minus the 10 plus the 9. Let's plus the 9 so I don't forget. I need to minus the 10. Not yet. Not yet. Yet not. Yes, it makes sense. Okay. So here we want to minus the 10 again, but we don't have enough. So what do? Minus the 10 plus the 9. Minus the 10 plus the 9. Let's plus the 9 again so we don't forget. Minus the 10, not enough. Minus the 10 plus the 9. Minus the 10. Minus the 10 plus the 9. Minus the 10 plus the 9. So I'm going to plus the 9 again, and I'm going to take away the 10. Is there enough to take away the 10? Yes. Oh, yeah, it does. Okay, good. So we minus the 10. So we stop here. We know to stop because we already did the action. But the thing is to keep track of what you have done. That's the one thing. And I can see kids getting confused. But if they go too fast, they will misstep. But I am going to head out. Thank you again for joining me. Oh, I hope this was okay. But it's good to be able to. But see, that's what I'm saying, right? Like, adding and subtracting is really underrated. Like, we think that the kids should know the answers, but it's about the process, and the process about this. Thank you. I will keep storing. Yeah, that'd be fantastic. You know what? Come with your questions, and we will start working it out. Yes, it was good to see you too. Thank you. Let me stopping by. Yeah, I was like, wait a minute. I'll keep stopping by. Yeah. If you have questions, just like what Alma gave us, right? And we can talk about it and we will slowly break it down. Let me know if you have any more math questions, abacus questions, math questions. So it's adding, subtraction, multiplication, division. So afterwards we can do multiplication. But I wanted to really solidify our addition. So thank you again, everybody, for joining, and then have a good day, and I will see you later on my next live. Thank you so much for the follow, Otter. All right. Have a good day. Bye.